Okay. How will a face portrait for this ODE look like? Sorry. How will the face portrait of this system here will look like? Is it something that is living here? Is it something that is living here? Or is it something that lives here? So the first one, let's make it in gray. The face portrait is here. The face portrait is here on this axis. The face portrait is something like here. 3. It's a first order ODE, autonomous ODE. 2. True? Because in a certain sense, the face portrait is a trajectory that looks like something where you do not see time. Here we do not see time. True? And it's something on the right-hand side of the equation. In this case, we have y dot is equal to f of y. True? It means it's something here. Can we see in a good way a face portrait of a first order system? No, because everything is going to be on top of each other. We do not see anything. The face portrait would seem like something that is from here we have something like this, from here something that looks like this, from here something that looks like this, and we wouldn't see anything. Okay, so face portraits with first order systems, you do not see them well. Whenever we have a first order system, we are going to use the time perspective. Okay, together. This one is kind of obvious. Why doesn't go Control Plus now? Control Plus doesn't work anymore. Why Control Plus doesn't work? Don't know. Now it works. It's mysteries. In Italian we say misteri della fede. What do you see here that is interesting? Go. This is a face portrait. Discuss this face portrait. What is interesting about this face portrait? Which point do you find that is very, very interesting? And why? Okay, people, look at me. This point here, this one that I'm doing in big here, this one very likely it's an equilibrium, true? What is interesting of this equilibrium? Some trajectories go inside, some trajectory go outside, true? Together? Is actually something that is very often happening in a certain. Think at the. Buonanotte. If we go back here, zoom a little bit more. We cannot make it. If we think at this stuff here, this goes like this and this, true? And it's like this and this, true? Together, you see? Because we arrive, but we also escape, true? So this kind of behavior happens often. Sometimes it happens that I've got everything that goes inside. Sometimes I've got everything that goes outside. We are going to play some games about this stuff here. There's a game that we're going to play with this type of behavior. If everything, all the trajectory go inside, we kind of will say, we will see it in a formal way better on later on, this is going to be asymptotically stable, because in a certain sense, it's an attractor. The equilibrium is an attractor. True? I start a little bit far and I'm attracted back. If I've got some stuff that escapes, that is going to be unstable. Okay? And watch out that it's important to have, it's enough to have just one trajectory that escapes to have instability. If we think at a nuclear explosion, we have one trajectory that explodes. True? It's a bomb. Typically it's there, sitting there, but it might explode. Since there's at least one trajectory that might explode, in a certain sense it will be an equilibrium or a system that we will need to be taking care in a special way. You see the point? Perfect.
But why do we say that, how can you say that it's likely an equilibrium point at one without having information about the first derivative of our function?
Because if we have that stuff there, just a moment, I don't remember anymore what the point that I need to put. Let's try 360. I will fix later on. Let's go here. Rabbits, foxes, and then do a face portrait, and I do a face portrait that looks like this. This face portrait is kind of a very weird face portrait, because if I take this point will be an initial condition, true? And from an initial condition, I would have two trajectories. This would be a non-deterministic system. True? A system that depends on chances, you're going to take a different trajectory. I skip this part here, but we do not work with this type of systems in this course. They are much more complicated systems. We need to use Ito integrals. Very nasty mathematical stuff, okay? Very nasty mathematical stuff. So in a certain sense, whenever we see two things that intersect, that has to be an initial condition that is well defined. It has to be an equilibrium. Because if it is not an equilibrium, it means that we have stochasticity. You see? Are we together? It's an excellent question. This is an excellent question. It's a kind of a very fine thingy. As you might see, I'm kind of skipping some details because otherwise we get stuck on a specific mathematical thing and we do not go on. Whenever you started learning reading, did you start reading Wikipedia in Gothic? No. You started reading these, true? In a certain sense, I'm trying to do the same. I'm kind of skipping some details and we do iterative learning and we go more and more into deep, in digging in. Okay, so I know that I'm fishy in some parts, but it's on purpose. Okay, because otherwise we get stuck on something that is very theoretical, very mathematical at the beginning, and I've got the feeling that it's not instrumental for you to learn as much as possible. Together, and of course it's a teaching choice, and whenever you choose something, you might have different things. Okay, we got the point that in face portraits we might have different face portraits. Okay, together they are representations, and you will learn also to plot face portraits because we are going to see them tomorrow, for example. You are going to do. Okay, so what is the primary purpose of a face portrait? 440. Remember me 440. The zoom, setting the zoom at 440. Okay, people, what would you say here? Very easy question. Okay. Now, just to make you kind of feel safe, the pre-oral exam, you know that there's this pre-written, pre-oral, pre-exam. There are going to be questions like those ones. Okay. We are together that somehow, if you do not know how to answer this stuff here, at the end of the course, we are in big trouble. So, we are perfect. Okay. Excellent. Another thing that I wanted to say, okay, the reflection prompts and these metacognition activities that you see at the end in the slides, are you using them? They are new. This is very new. This is very, very, very new. First time that I'm using them in life. I would like to know if you find them useful, and of course use them if you find them useful. But they are drafted so to kind of help you be aware. Okay. Questions before going on? No. Let's do